Have you ever wondered why the sky is blue and not purple? Long before science, people explained the sky with stories, that is, gods, goddesses, and celestial domes. Thus the Egyptians saw the sky as the goddess Nut, whereas the Greeks imagined a dome of brass. Blue was the colour of divinity and infinity, but as civilizations grew, so did our curiosity. Greek philosophers like Aristotle began seeking natural explanations, suggesting the blue was diluted sunlight. Leonardo da Vinci noticed blue smoke and guessed that air itself played a role. He was close. Sunlight and air interact to create the sky's colour. The scientific revolution brought tools like prisms and spectroscopes, letting us study light itself. Scientists could now experiment, measure, and test their ideas. The question shifted from who made the sky blue to what makes the sky blue. To understand this, we must first understand sunlight. Sunlight looks white, but it's actually a blend of all the rainbow's colours. Isaac Newton proved this by passing sunlight through a prism, revealing a spectrum of red, orange, yellow, green, blue, indigo and violet. Each colour is a wave of light, but not all waves are the same. Red light has long, gentler waves. Blue and violet have short, choppy ones with higher energy. This difference in wavelength is crucial as it determines how each colour interacts with the world. Amazing, right? All these colours travel together from the sun, appearing white to our eyes. But when they reach Earth's atmosphere, something remarkable happens. The light waves plunge into a sea of air, and their journey is disrupted. Here, the secret of the sky's colour is revealed. The atmosphere acts as a filter separating the colours. The stage is set for the blue sky's grand reveal. The answer lies in how these waves meet the air. Let's see what happens next. Before sunlight reaches us, it must pass through Earth's atmosphere. From space, it's a fragile blue haze. From the ground, it stretches and extends far beyond. Without it, our sky would be black even during the day because there would be no particles to scatter sunlight. The atmosphere is mostly nitrogen and oxygen, filled with countless tiny molecules. These molecules are far smaller than the wavelength of light. When sunlight enters this ocean of air, it collides with these invisible particles. This interaction is the key to the sky's colour. Otherwise, without an atmosphere, like in the case with the moon, the sky is always black. But Earth's unique mix of sunlight and air creates the blue spectacle we see. The atmosphere transforms sunlight into a daily display of colour. Now let's see how light and air create the blue sky. When sunlight meets the atmosphere, a fascinating process called scattering begins, setting the stage for the colours we see above us every day. Imagine sunlight as a stream of coloured waves, each with its own unique energy, colliding with countless tiny gas molecules that make up our atmosphere. These molecules act like miniature obstacles, scattering the incoming light in all directions. But here's the interesting part. Not all colours are scattered equally, and that's where the magic happens. Blue and violet light, which have shorter wavelengths and higher energy, are scattered much more than the longer wavelengths of red or yellow light. Think of it like rolling small balls through a crowded field of posts. The smaller balls, representing blue light, bounce and scatter everywhere, while the larger ones, like red light, pass through with fewer interruptions. This is why, when you look up, you see blue light coming from every direction, as if the sky itself is glowing with a gentle, endless blue. The sky appears blue because blue light is scattered across the entire dome above us, filling the atmosphere with its vibrant hue. Meanwhile, red and yellow light travel more directly through the air, making the sun itself look yellowish-white, especially when it's high overhead. The scattered blue fills the sky, creating the familiar color we know so well, a color that changes subtly with the time of day and the angle of the sun. It's a simple process with a beautiful result, turning our sky into a living canvas that shifts and glows as the sun moves. The blue you see is sunlight, scattered and sent to your eyes from every corner of the atmosphere, connecting you to the vastness above. That's the magic of scattering, a simple dance of light and air that paints our world with wonder every single day. Our understanding of the blue sky comes from the work of brilliant scientists. In the 1860s, John Tyndall showed that tiny particles scatter blue light more than red, a clue to the sky's colour. Lord Rayleigh took it further, mathematically proving that small molecules scatter short wavelengths, like blue, far more than long ones, like red. His law, Rayleigh's scattering, explained why the sky is blue. Tiny gas molecules scatter blue light, around 10 times more than red. But the story didn't end there. In the 1920s, C.V. Raman discovered that a tiny fraction of scattered light changes wavelength. That is a quantum insight known as the Raman effect. While Rayleigh scattering explains the blue sky, Raman's work deepened our understanding of light and matter. It revealed another subtle way light interacts with matter. Together, Tyndall, Rayleigh and Raman turned a simple question into a window on the laws of physics. Their discoveries show how curiosity leads to profound breakthroughs. The blue sky is a triumph of human inquiry. Science turned wonder into understanding. Rayleigh's scattering doesn't just explain blue skies, it also creates the fiery reds and oranges of sunrise and sunset. When the sun is high, its light passes through less atmosphere, scattering blue light across the sky. But at sunset, sunlight travels through much more air, scattering away most of the blue and violet. Only the longer wavelengths, like red, orange and yellow, make it through, painting the sky in brilliant hues. The sun appears as a glowing red or orange ball on the horizon. Clouds and dust catch this warm light, amplifying the spectacle. Sunrises work the same way in reverse. The colors we see are a daily demonstration of light scattering in action. The blue of midday and the red of sunset are two sides of the same coin. Every sunset is a lesson in physics and a moment of beauty. The sky's color is never quite the same from one moment to the next. It shifts and transforms with the weather, the time of day, and even the season. Each change tells us something new about the world above. On cloudy days, the sky turns a dull grey because clouds are made of countless water droplets, each much larger than the tiny gas molecules that make up the clear sky. These droplets scatter all colors of sunlight equally. This process is called scattering. That's why clouds can look bright white on some days, or heavy and grey when they're thick with moisture. When clouds are especially dense, they block out much of the sunlight, casting a shadow over the land and making the sky appear even darker and more dramatic. But have you ever wondered why the sky isn't violet, even though violet light scatters more than blue? The answer lies in both the sun and our own eyes. The sun emits less violet light than blue, and our eyes are much less sensitive to violet wavelengths. Plus, much of the violet light is scattered away before it ever reaches us. That's why, when we look up, we see a brilliant blue sky instead of a violet one, especially during the middle of the day. But during twilight, when the sun is low and the atmosphere is clear, you might catch a fleeting glimpse of violet or purple hues high above, painting the sky with rare and beautiful colors. The sky's ever-changing palette is like a visual report, revealing the secrets of the air above us and the light that travels through it. From the deep blue of a clear day, to the somber grey of a storm, to the magical violet of twilight, every shade tells a story about the dance between sunlight and atmosphere. So what is our conclusion? Sunlight, a blend of all colors, travels through space and enters our atmosphere. Tiny gas molecules scatter blue light in every direction, filling the sky with its color. The same process gives us sunsets, white clouds, and grey skies. Every hue is a message about the interplay of light and air. From ancient myths to modern science, our quest to understand the sky's color is a journey from wonder to knowledge. And it all began with a simple question. Like, share and subscribe.